Most of the technologies that we've seen use one building material in addition to a support material. And it's important to note, different colors are not the same as different material properties. Digital materials are composite materials produced by depositing two or more materials simultaneously in specific concentrations and structures. There is no chemical mixing of the materials except in the boundaries. Each drop is placed in its precise location. The drawings demonstrate possible structures. In A, the spread of material B can be randomly spread inside matrix mix made from material A. In B, material B can be placed in a unidirectional manner, but with random traits such as length, thickness, and location. In C, material B can be placed in an orderly unidirectional manner. And in D, material B can be with an identical ratio and in an organized structure with respect to material A. In the digital material process, a multimedia model is produced in a single print, requiring no assembly. It incorporates multiple textures using digital materials which combine two base materials. Digital materials are a subfield in multi-material printing. Digital materials offer some advantages for multi-material printing. The production of functionally graded materials with varying SHOR A values within a single part can be achieved. Most products are not homogeneously constructed. Digital materials allow the production of heterogeneous products. Digital materials produce more isotropic parts than some other technologies. And digital material structure changes with respect to the geometry of the object. FDM, or fused deposition modeling, is one of the most common types. In this process, a plastic filament is melted and extruded through a nozzle. Parts are built by laying down layer upon layer. A fused deposition modeling machine melts a plastic filament and extrudes it through a nozzle. The melted material is laid down on the build platform where it cools and solidifies. By laying down layer on layer, the part is built. FDM, or fused deposition modeling, requires support structures which anchors the part to the build platform and supports overhanging structures. Through the use of a second nozzle, the support structure can be built in a different material. Several parts can be produced at the same time as long as they are all anchored to the build platform. Layering of parts on top of each other can cause problems with heat dissipation. FDM has many advantages, including the ability to make fully functional parts in standard plastics. FDM models work with standard materials such as ABS or polycarbonates and PLA. Therefore, parts have good mechanical properties and are durable over time. Parts can be post-processed as any plastic part produced within conventional machining. Through the deposition of extruded material layer by layer, parts have anti-isotropic in the Z direction. The surface has a step structure and fine details cannot be realized. Prototypes are produced for form and fit as well as functional testing in standard materials. Another common application is in the use of jigs and fixtures, as well as small series parts down to one of a kind are built in standard materials by FDM. The following parts show the typical detail capable in FDM. And the final part shows the difficulty with making small curved structures.